Hello guys, this is Alan, and today I will be your Coding Minds Academy instructor, Minecraft Python. Woo! And here we have already, in the previous two lectures, we have already seen how these Python modules can work in Minecraft in the general concept, and with some basics that we learn in Python, such as built-in variables, assignments, and these functions and how the loop control works. These kind of stuff, we're going to put them up together in today's lecture, where I'm going to demonstrate two usages of the Python packages in Minecraft so that we can automate the process a little bit. So the first package that I want to show is called MCPI, with in full name called MinecraftPI, which basically they just migrate the Raspberry Pi platform edition of Minecraft and to be implemented on a computer-based platform, and we can use some Python to make some automated commands so that we don't need to manually build up blocks that we want. I'm going to share my screen about the code first, and then we're going to go to the while we're running the code, we're going to see how the Minecraft uh, portal going to react. So here it is. In the first part, where I'm going to demonstrate a quick example of how to set a Nether Portal randomly near player. And in this process, I included a process that randomly reset the player's position. And after that, I just have a set at the place that's set where the Nether Portal is going to be set. And we can go through the chunks of the code together at the same time. And in the first part, I just created a server instance. So, we can run Minecraft locally on our computer, and the MCPI the module where the Minecraft object exists can help us to realize this function. And then I found the player's coordinates, and there are three attributes from the get path function from the MC module, and you can see that XYZ will be used later in the code. And after the position is found, I'm trying to set up the offset that I'm gonna use for randomly reset the player's position. So the random module here helps us to generate random integers between opt min and opt max. Here I just set as 1 and 10. And the scale is pretty much the multiplication. How much do you want to enlarge the offsets? Here just apply 1 for simplicity. And the last part will be the one to set up the Nether Portal. And it's just the most interesting part because it's always been calling a function called setBlock from the Minecraft module, which basically just add the offset based on the based on player's position. And here I'm just only using the original position of the player, so that even though when a player has been lifted up to sky, the usual generation of the blocks can still happen in a content that is close to the ground a little bit. And by having the numbers over here, we'll be able to see how these widths, the offset and construction will work. And within this part of code, there's actually an error that I want to fix. Can everybody give a quick shot on what it is? Right. It is the y plus 4, we don't want any full and kind of non-zero and non-one values appearing within our code. So if we go back to the constant module that I have before, you can find that that void is the width that I want to use to implement the Nether Portal. So why don't we just replace that with Nether width? There we go. And by doing this, I basically will just be able to set up the two rows of the Nether Portal. I'll call it base at the top. And finally, I introduce to the 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 height of the needle, but I need to remember that I only need to fill up the gap between the top and the base. So by having some code here where I was able to just start from the base and then go to the width of the needle, and I just need to update the y coordinates while having the base remain at the same. Actually, make it better. I can try to refactor both 1 to be base as well, because base I equals to 1. And now part 1 just ends. Let's see how the code is gonna work. I will click run, and we go back to Minecraft, and we will be able to see. So the program has already ended. So if I stop sharing and open the Minecraft portal, we'll find that, there we go. I just had a Nether portal spawned in front of me. And this is, it looks like play just start from the, it's just starting from a very high in the sky and then just fall down. But the offset's very tiny because you see there's only just only one block that between in terms of diagonal. So yeah, that's basically how MC MicroPy works. And let's go look at the second example. So I'll stop sharing. The second example, I'll cover the usage of MinecraftTurtle, which is kind of like Python turtle-like module that can help us automatically generate any kind of pattern that we want. And in this case, we'll be able to see that in my screen sharing, share back, Minecraft demo, share, and we'll be able to see that the MCTurtle module actually contains one more line of imports, which is basically the MinecraftTurtle object from MinecraftStuff module. It basically has the same start and basically just reconnect the server and find the location of the player. And just a heads up, we probably use my pause with concatenated by a underline because Python prefers no camel case, but just like plain lowercase letters with underlines as variable names. And although the author of the modules use the camel cases, we just insert coding in Python, which make sure we have this kind of corresponding usage. And following, I just create a turtle object, also finding the x and z coordinates of the participant player. And here, a point to remember is that we need to set the starting point of the turtle in the x and z direction 1 unit away from us, because if we start at the original point, it's actually going to block out our position. We can see that in Minecraft. And always remember to update the player's x and z values so that later on we can use that to perform some clearing operations. And my example here is to draw number 8 first, but with a black stroke, and then draw number 9 to that replace these blocks of number 8, and also make some clearing up operation at the end. So to start, I just had a for loop that actually takes the turtle to draw the bottom part of number 8, and then I lift up the pen so that it won't be able to draw anymore, and then move to the upper right corner of the bottom half, and then start to draw the top half of number 8. And it's followed by a pen down because we need to start drawing with the black stroke. And in the second for loop, I include the if else chain because in the last iteration of the for loop, we can find that the center, the edge in the middle of number 8 has been shared, so that we don't need to draw any more blocks. So when it comes to the last iteration, I lift up the pen, just move forward the turtle, and then put down the pen. While at the other times, I just move forward. And at all the time, I make sure I gotta turn left all the time. So this is number 8, and I'm gonna finish. And then I moved on to the iron blocks so that I can be able to draw number 9. So pen block helped me to do that, and a full loop just helped me to draw the top square of number 9. Remember, we had the position already been correctly set from the last turn of number 8's top half. So we just need to go forward and make sure we turn left at each iteration. And at the end, we go back to the original position and as well as the rotation. But remember, we need to get the 2 red strokes of number 9 painted. That means how many degrees we're gonna need to turn. Can everybody give a quick shot? Is it 90? Is it like 260, 270? It's actually not, it's actually 180 because we just need to turn the orientation that faces to the starting left to the position where the ending to where the position that's right opposite as the left position to be able to draw the rest 2 strokes. So having that, remember only need to turn twice because there's only 2 strokes as stored as a constant, and then we acquire the position of the player, and by having that over my updated part of the of the block settings when the 2 strokes are done. And remember, there's 4 blocks left by the previous drawing of number 8 between the bottom stroke of number 9 and the bottom line of the top square of number 9. And to replace these 4 black strokes, I just use the air block to reset the position of the blocks. And let's look at the code and see how it's going to work. I run on MinecraftTurtle and go back to the game, but stop sharing and then quickly sharing the screen back to Minecraft. We should be able to see that there's something start drawing. Oh, right on, all right. And yeah, for this moment, oh, this is the door that we just generated, whatever. And we should be able to see from, we just look up the sky. We should be able to see that, the number 8 is already drawn, and the go around a bit, and then number 9 comes with the super iron blocks. And then it continues with the 2 strokes, and then it ends at the bottom left. Finally, it replaces the 4 blocks with the air blocks. That's my demonstration for the project, and I hope you all have enjoyed how these 2 modules going to work. And to be honest, there are more functions that we will be able to explore throughout these 2 modules. This is just a way of quickly automating any kind of pattern that you want to construct in the game, so that it kind of augments your game experience. Stop sharing and go back to the main screen. I hope you all have enjoyed today's session, and please let me know if you have any questions, and I'll see you guys in the next lecture. Bye.